So welcome guys, good morning. Okay, so we are doing this space technology. Okay, and in the space technology, we started with satellites yesterday. Yes, and in the satellites, first we have seen experimental. Yes, April 19, Aryabhat, 1975. Okay, and then university satellites, and I have told you two examples. This Annamalai University, SRM University. Okay, so these two universities examples I have told you, and then we started with uh, remote sensing satellites. Remote sensing satellites. Okay, so these remote sensing satellites we have seen the applications in the disaster management, agriculture, forest, minerals, urban planning. Okay, so everything we have seen. Today we're gonna see Earth observation satellite. Earth observation satellite. Okay, right. Most of the features of most of the features of Earth observation satellite EOS and Raskon. I mean, write it as EOS. Most of the features of Earth observation satellite EOS are similar to remote sensing satellites, RS satellites. Most of the features of Earth observation satellites are similar to ROS. But in some cases, next point, but in some cases, Earth observation satellite is so advanced. But in some cases, Earth observation satellite are so advanced. Next point, they can do they can do study of study of fractional changes fractional changes on the Earth surface. They can do study of fractional changes on the Earth surface. Okay, see what's the difference. We have seen remote sensing. Okay, and now we are seeing Earth observation satellite. Okay, difference is, see, here also we'll get to know the changes, and here also we'll get to know the changes. Okay, but let me give you some examples. Let's say this is ice. Okay, if this is melting into water, this is melting into water, this will get to know in remote sensing, and this will get to know in Earth observation satellite as well. Okay, but at what rate this ice is melting into water, this will get to know with the help of Earth observation satellite. Okay, and let's say, see, there is an earthquake. If the scale is more than 6 or 7, then we'll get to know with the help of remote sensing satellites and Earth observation satellite as well. But if the scale is low, 4 or 5, okay, you might not be feeling the earthquake, but still this Earth observation satellite will tell you there the earthquake has happened. Okay, see, generally in the morning whenever you're waking up, people will say you, like, I mean, see, there is a there is a earthquake. Okay, but you feel like, I mean, I haven't sensed it. Okay, who sensed it? Actually, this Earth observation satellite sensed it. Okay, and right down. One more example is, see, this lakes in the summer. Okay, they will convert into vapors, dryness of lakes. Okay, okay, this we can observe through remote sensing laptop satellites. Okay, but at what rate the water is converting into vapor, this we can get to know with the help of Earth observation satellites. Okay, which means both are same, but this is advanced. Both are same, but this is advanced. Done. Right. Examples: rate of melting of ice in polar areas. Rate of melting of ice in polar areas. Rate of melting of ice in polar areas. Next example: rate of dryness of lakes. Rate of dryness of lakes. Okay, these are the two examples. Okay, let's say if this question comes in UPSC, what you have to do is, okay, first you have to write down the applications of all the remote sensing satellites, and then add these 2 points. Okay, so it will observe the fractional changes on the Earth surface. Okay, fractional changes means, example, these two. Okay, the rate at which the ice is melting, the rate of dryness of water. Okay, these things you can observe through Earth observation satellite. Okay, next, write down. The first EOS by India is, Earth observation satellite by India is synthetic aperture radar. Synthetic aperture radar, SAR, which was in the year of 2012. Okay, see, this was happened in 2012. Okay, we have launched a satellite which is synthetic aperture radar. Okay, this technology is new to the world. Even this USA is also not having this technology. So what happened is, USA came to India, and USA asked India, India, can we make a deal? Trade deals, you remember, in economy. Okay, so it came to India and it asked India, India, can we make a deal? What kind of deal? Can you share the technology? We said, no, we can't share the technology. Then it asked, can we make a project together? Then India said yes, and the project is Nisar. 2014, right? NASA plus ISRO plus, on which technology they are working together? SAR. So the project name is N from NASA, I from ISRO, and the technology is SAR. So the technology name is NISAR. The project name is NISAR. Okay, and this year they are going to launch this NISAR. After this NVS2, yesterday they have launched NVS2, right? So after this, they are going to launch this NISAR. Okay, so what happened here is, in 2015, they have set up the joint steering group, which means a committee. Steering group, like how to proceed further with this project called NISAR. Okay, so the next time, I mean, soon we're gonna see this. Okay, at that point of time, don't think this is current affairs. This has already happened in 2014. Okay, so NISAR is nothing but Earth observation satellite. Okay, which is a joint project of NASA and ISRO. They are working on SAR technology, synthetic aperture radar. That's the reason we'll call this as NISAR. Okay, now see, in this joint meeting, they have decided their contributions. They have decided their contributions. Like NASA, they came up with their contributions, and India, they decided their contributions. Okay, so NASA L-band synthetic aperture radar. Okay, and GPS will be provided by NASA. Okay, and then data recorder will be by NASA. These three are the contributions of NASA. Okay, so what are these things? Leave it. Okay, later everything you'll understand. Okay, once I'll done with this science and tech lectures, there is no single term that you don't understand. Everything you'll understand, but in the right time. Okay, next, see ISRO. ISRO contributions. ISRO contributions. S bands are synthetic aperture radar. Okay, and spacecraft bus. Okay, and then data transmission system. Data transmission system. Okay, spacecraft integration. Spacecraft integration. And the launching vehicle, which is GSLV. Okay, and on orbit operations and testing. On orbit operations and testing. These are the contributions of ISRO. See, the original technology is ISRO technology. That's the reason ISRO is taking more role here, and it is giving less role to USA. Okay, see, these all things, okay, quite technical. Later you'll get to know. Okay, and here this today you'll get to know GSLV. And on orbit operations means I'll show you an animation. Okay, there you will get to know. See, we'll have stages of rockets. Okay, with the stages of rockets, what we'll do is we'll try to launch the satellite in the orbit. Okay, in the end stage, what we are trying to do, we are trying to launch the satellite in the orbit. So that launching process is nothing but on orbit process operations. Okay, once it has gone there, before we'll do so many tests. Okay, the testing responsibility is also ISRO. Okay, now write down specifications. Specifications of this NISAR. Specifications. Specifications. First one. By 2025, which means this year, soon they are going to launch this. Okay. Second one, orbit. Polar sun synchronous orbit. Understood this one? Earth observation satellite. So obviously we have to launch either in polar satellite orbit or polar sun synchronous orbit. So here they are choosing the best one, which is polar sun synchronous orbit. Now altitude, at what height they are going to launch, which is 747 kilometers. 747 kilometers. Inclination angle, 98.4 degrees. See, understood this one? Yes. If they are launching in polar orbit, then they would have launched this in 90 degrees. But to get rid of the shadow, what they have to do? They have to give some inclination. And that inclination angle is 8.4 at an altitude of 747. Okay. So this inclination will be varying from height to height. Okay. If the height is varied, then this inclination will change. Yes. So at this particular height, 747 kilometers from the Earth's surface, the inclination needed is 98.4. Okay. Lifespan 3 years. Lifespan 3 years. Lifespan 3 years. Okay. And write down, keep a note point and write down. It will scan the entire globe in 12 days. It will scan the entire globe in 12 days. It will scan the entire globe in 12 days. It will scan the entire globe in 12 days. It will scan the entire globe in 12 days. Okay. See, soon they're gonna launch this satellite. Now that will come into your current affairs. Now in the current affairs, these points only there. One is by 2025, this will be eliminated because already launched. Second point is polar sun synchronous orbit. Before my lectures, this might be a difficult term for you, but now this is easy peasy for you. Next, altitude 747, which means this is in the polar orbit. Which means this is in the polar orbit. And one thing is sure, this is sun synchronous orbit, so we need an inclination. That inclination is 8.4. Okay. And I have told you every satellite will have a lifespan. Even sun also is having a lifespan. Even Earth is also having a lifespan. Okay. So the lifespan of this satellite is 3 years. Okay. So these things you are going to read in future as a current affairs. Okay. And the most important thing is it will scan the entire globe in 12 days. Fine. Yes. Now we are left with one more satellite, which is INSAT or GSAT. INSAT or GSAT. Okay. First thing is, what is INSAT, what is GSAT? INSAT means Indian satellite. Indian satellite. GSAT means geostationary satellite. A geostationary satellite. Okay. Now see. Now what happens here is, obviously these are placed in geo orbit, which means geostationary Earth orbit or geostationary synchronous orbit or geosynchronous transfer orbit. Okay. First thing is clear. Second thing is, before we don't have this technology, launching vehicles technology. Then what we used to do, we used to carry our satellites through a ship and we used to go through French Guiana, and there we used to launch our satellites. Okay. There what used to happen is, every country's satellites will reach there. Okay. So to differentiate between the country's satellites, what they used to do is, this is Indian satellite, so INSAT. This is USA satellite, so USSat. This is Australia satellite, so ASAT. So they used to give the names like this, and they used to launch the satellites with the help of their launching vehicles. Yesterday we have seen International Launching Station. So whenever we are launching our satellites in the International Launching Station, then we'll call them as INSAT. Okay. If we are launching these satellites in our country with our launching vehicles, then we'll call this as geostationary satellites. Simple? Clear? Yes? Right on. Before we don't have technology of launching vehicles. We don't have the technology of launching vehicles. Launch vehicles today we're gonna learn. Okay. We don't have the technology of launching vehicles. So we used to launch our satellites with the help of foreign technology. We used to launch our vehicles with the help of foreign technology. We used to launch our vehicles with the help of foreign technology. Foreign technology. Foreign technology. So they have given the name called India satellite. So they have given the name called Indian satellite. They have given the name called Indian satellite. Next point. Next point. Once we developed our indigenous technology, once we developed our indigenous technology, once we developed our indigenous technology, we started calling the same satellites as geostationary satellites. Geostationary satellites. Geostationary satellites. Geostationary satellites. Okay, done. Now write down the this is also called as, write down, this is also called as multi-purpose satellite. Multi-purpose satellite. Multi-purpose satellite. Multi-purpose satellite. Why this is called as multi-purpose satellite, I'll tell you. Okay, see, this can do the task of this Earth observation satellite, remote sensing satellite as well. Like, I mean, they'll help us with weather casting, okay, weather forecasting. So this will also help us. But the thing here is that is more effective because that is in the polar region, which means from 50 kilometers to 2000 kilometers. This is somewhere around 36,000 kilometers. Okay, so which one will be more effective to forecast the weather? Obviously the orbits which are in the polar region, right? Yes, if I'm close to you, I know better. If somebody is looking from to you from far away distance, then he knows less about you, right? Similarly, this will also do the tasks which are done by those two satellites. But the thing here is they are more effective. They are more effective. Okay, then what is the purpose of this satellite? I have already told you. First one is applications, right now. Telecommunications, I have told you. Yes. Geostationary Earth orbit, here what happens is it will focus at a particular region from 36,000 kilometers and it will give 24 by 7 services. Okay, and the applications are telecommunications, comma, write down, broadcasting. Broadcasting, which means your television. Okay, satellite news. Satellite news, which means satellite phones. Okay, for now take it as satellite phones. Internet. 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 DTH. Internet. DTH. DTH. Okay, next one, search and rescue operations. Search and rescue operations. Search and rescue operations. If any accidents are happening, there the search and rescue operations will be done by this satellite. Okay, let's say, I mean, this Rajashekar Reddy incident happened, right? Okay, so helicopter collapse. Okay, first where it is exactly, that information will get to know by this satellite. Later we'll send a rescue team. Okay, they'll reach there and they'll find the remaining things. But initially, to find the location, which satellite we are using? This one. Okay, next, weather forecasting. But which one is more effective? Weather forecasting. In bracket, write down RS and EOS are more effective. Remote sensing and Earth observation satellites are more effective. Okay, next, navigation, this regional GPS, regional GPS. Okay, one is this Gagan. Okay, we'll read about all these things later part. Okay, and IRNSS, Gagan and IRNSS. Okay, here write down Indian regional navigation, Indian regional navigation satellite system, Indian regional navigation satellite system, Indian regional navigation satellite system. So I mean, I'm giving you a glance, later I'll tell you again. Okay, so write down, this is a constellation of 7 satellites. This is a constellation means all these 7 satellites will work together. Okay, this is a constellation of 7 satellites. This is the constellation of 7 satellites. 3 are in GTO, geosynchronous transfer orbit, and 4 are in geostationary Earth orbit. Okay, see, yesterday you have seen a news, right? Which is NVS 02. So already 3 satellites are launched in the GTO. Okay, out of one, they have replaced with NVS 02. Okay, so NVS 02 is nothing but regional navigation system. Okay, Navik, part of Indian Navik system, regional navigation system. Okay, so what this NVS2 will do is, it will define the routes for the local. I mean, see, for local routes also we cannot depend on GPS system, and for military kind of operations we cannot completely depend on GPS, because USA will have the data and slowly USA will give information to Pakistan. So that's the reason, at least for military operations, we cannot depend on a GPS system. So we should have a regional navigation system. For the regional navigation system, we have developed a technology called this Navik. Under Navik, we have sent 2 satellites. One is Gagan, second one is IRNSS. This IRNSS is a constellation of 7 satellites. Okay, 3 are in GTO and 4 are in, which means 4 are circular orbit and 3 are elliptical orbit. Okay, and one of that, yesterday it was replaced with NVS 02. Okay, before this was sent using PSLV. Okay, but yesterday, if you would have seen the news, it has sent with GSLV F-15. Okay, why this has happened, I'll tell you in the launch vehicles. Okay, now keep a note point. Keep a note point and write down. Air, All India Radio. Air, All India Radio. Air, Doordarshan. Doordarshan. Department of Telecommunications. Department of Telecommunications. Department of Science and Technology. Department of Science and Technology. These ministries will use GSAT satellites. These ministries will use GSAT satellites. Okay, these ministries will use GSAT satellites. These ministries will use GSAT satellites. Okay, now first INSAT, first INSAT, first INSAT, okay, series of satellite, first INSAT series of satellite, okay, which is INSAT 1B, INSAT 1B, which is in 1983. So first INSAT satellite launched by India is in the year of 1983, and the satellite name is INSAT 1B. Now tell me, here the name is INSAT. Here the name is INSAT. Now tell me, using our technology or using foreign technology we have launched this satellite? Using foreign technology. That's the reason we are calling this as INSAT. Okay. So indigenous technology in 2001 we have launched. So we have to call this as GSAT. Okay. And the name of the satellite is GSAT D5. GSLV launch vehicle is GSLV D5. GSLV D5 launch vehicle is GSLV D5. Okay, this is GSAT 1A only. Okay, successfully we have launched the first one, and the name is GSAT 1A using vehicle GSLV D5. So this is our technology, our launching vehicle. So using this vehicle we are launching, so we will call this as GSAT. Understood? INSAT, GSAT, INSAT using foreign technology. If you are using indigenous technology, then we'll call this as GSAT. Yes, clear? Satellites. We have seen how many types of satellites? Experimental, university, then remote sensing, Earth observation, and then INSAT or GSAT. Okay. Now let me tell you something. See here, if you want internet services or regional navigation system, will mainly dependent on this INSAT or GSAT. Okay. For Earth observation, remaining all the things, remote sensing activities, everything will dependent on remote sensing and Earth observation satellites. Okay. So if somebody is sending any satellite, okay, which is okay in the orbit, okay, in the inner orbit of the Earth, then it must be of three kinds. One is remote sensing, Earth observation, or it will be GSLV. If it is of remote sensing or Earth observatory satellites, then it will revolve around the Earth. It will cover entire globe. It will cover entire globe. If they are launching GSAT, then obviously it will focus on a particular area from 36,000 kilometers, and it will provide 24/7 services. Okay. So this is the gist of satellites. Only three satellites we have. Okay. In the three also two are similar, but one is most advanced. Okay. Now, last somebody asked me this question. See, using this remote sensing and this Earth observation satellites, we can find the resources on the Earth. Yes, I have told you. See, when I say this, see, what happens is this is a particular area. Okay. Now this satellite will let you know somewhere here there are some resources. Okay. Somewhere here there are some resources. Let's say here we have found lithium. This is Jammu and Kashmir, and we have found lithium here. Okay. Now this satellite will tell you there is lithium in that soil. Okay. Now as a team we have to go there and we have to dig deeper. Then we'll get to know at what height it is. Okay. And at what amount it is. Okay. If the amount is larger, then we'll continue the operations. If the amount is in small scale, then we cannot continue the operations. But initial information will be provided by satellite. Okay. See how people will get to know their lithium resources are there. Initially, the information will be provided by satellites. Later, our team will go and they'll do the operations. Then they'll get to know at what height it is and at what amount it is. Understood? So the basic information will be given by remote sensing or Earth observation satellites. Clear? Yes? Now, next topic, launch vehicles. Launch vehicles. Okay. This is the mass of launch vehicle. Okay, so 50% mass of the launch vehicle is its own weight, its own weight. Okay, and remaining 50% mass is propulsion. When I say payload, payload will come here only. Okay, the satellites, okay, the cameras, sensors, everything will be coming under this. Okay, so see here, see, if we'll consider, let's say, 1000 tons, the mass of launch vehicle. Okay, generally it is mass, people will call it as weight, but generally it is mass. Okay, why we'll take it as mass? Because see, once will go up, okay, weight formula is mgh, so gravity will decrease, obviously weight will decrease. That's the reason we'll take this in terms of mass. Mass will not decrease, it will be constant. Okay, so here 50% mass is its own weight, and remaining 50%, which means almost 500 tons, is fuel. Is fuel. Okay, in here we'll have, see, these terms I'll explain you later. Okay, accelerometer, accelerometer, and then gyrometer. Gyrometer, why it is what is the use of gyrometer? Huh? Direction. C loop system. C loop system. Okay, so when I say own weight, these three things, I mean all the payloads will come. Okay, in the payloads we'll have accelerometer, gyrometer, and C loop. Okay, see, accelerometer means, see, here on the roads we have directions. So take this side, you'll get Vijayawada. Okay, take that side, you'll get Vishakhapatnam. So it will be shown over the roads, but in the space we don't have directions which is shown. So that's the reason there we'll use gyrometer. In the ships also we'll use this gyrometers. Okay, so gyrometer which will show us the direction. Okay, and the C loop system, this is programming of entire program of the launch vehicle. Okay, at what time it has to launch. Okay, till, I mean, at what kilometer it has to rotate. Okay, at what kilometers it has to inject into the orbit. Everything is nicely programmed, and the programming system is called a C loop system. Okay, right on. Okay, so here all the payloads will come. Along with that, see, this launch vehicle is made out of a material called merging steel. What is the steel name? Merging steel. Okay, see, this steel can sustain the friction of the atmosphere. Whenever we are going at a greater speed, okay, even the air will also create friction. So because of this friction, the vehicle will burn out. Okay, because it shouldn't be burned out, that's the reason we'll use a specific material called merging steel. Merging steel. Understand? This is material only. Simple. Now propulsion. What is propulsion? Propulsion means fuel. In the vehicles, if you are filling the fuel, then we'll call it as petrol. Okay. If in the heavy vehicles, if you are using, then we'll call it as diesel. Okay, but if in the launching vehicles, if we are using, then it will called as propulsion. It is called as propulsion. So generally what happens is, the example which I have told you, now I'll tell you again. See, this is my bike engine, this is my bike engine, and this is the piston. Okay, now what happens is, I'll fill the petrol. Okay. On the other side, there will be a pipe which is empty. Yes. What this pipe will do is this pipe will suck the air from the atmosphere. This pipe will suck the air from the atmosphere. Okay. Now, this will create a mixture of fuel and air. This will create a mixture of fuel and air. Okay. Now, if I'll burn this, then it will burn. Okay. Only fuel if I'm burning, it will not burn. Only air if I'll burning, it will not burn. See, I mean, in the 6th class science, you would have done an experiment. See, there is a candle. Initially, it is burning. Now, your faculty or teacher, now he'll take a glass and he'll keep on the candle. Slowly, the flame will be off. Why? Because the oxygen supply is gone, which means only fuel is not enough. So here fuel is the candle, wax. Okay. Along with the wax, what is needed? Oxygen is needed. Yes. If we have wax and oxygen, then only the fuel will be burned. If not the case, the fuel will not burn. Yes. Similarly, in your vehicle also, there is a pipe. This pipe will suck the air from the atmosphere and it will give to the fuel. Now there will be a nice mixture of fuel and air. Okay. Now this fuel will burn to give you the acceleration. To give you the acceleration. That's how your bike will be moving. Okay. If you want to move at higher speeds, it need a rich mixture. Okay. If you want to go slow, then also it needs rich mixture because their high torque is required. Okay. If you want to maintain average speed, then it needs medium mixture. Medium mixture. So that's the reason whenever you are going on average speed, it is taking medium mixture, so your mileage will be better. Understood? So high speeds, rich mixture, low speeds, rich mixture again, but in the medium speeds, economy speed. In your bike, it is shown as economy. Economy means it will save your money. How it will save your money? Medium fuel mixture will be used, which means less consumption of fuel will be happening there. Understood? So here my point is, to burn the fuel, we need oxygen. Okay. So here what happens is, in the propulsion, we have both fuel and oxidizer. We have both fuel and oxidizer. Why we are keeping oxidizer? Just like a bike, we can leave it aside to the atmosphere, right? But the thing here is, in the space, we don't have oxygen. So along with the petrol, here what we are doing? We are filling the oxygen also, oxidizer also. Okay. And you know what? This fuel is just 15%. Remaining 85% is oxidizer. One moment. Okay. So the point which you guys missed is, fuel is 15% and remaining 85% is oxidizer. Okay. Now see, I'll show you something. Can you see this? Yes. Can you see this? Okay. So see here. This is payload. This is payload. And remaining the material will comes under the own weight of the rocket. Remaining here, this, and this. These are all fuels. The point here I want to tell you is, here only the top part is your payload, which contains satellites. Okay, all the remaining systems of the rocket. Okay, so to inject in the orbit, remaining everything. You see, all these things. These are stages of fuel. These are stages of fuel. Okay, what is the use of stages? I will tell you. Okay, but this I want to tell you. See, if we are taking rocket, almost 50% weight is fuel. Remaining 50% is the weight of payload. Understood? So slowly what happens is, once it will start, first these two will be separated. Okay, slowly this fuel will burn. Okay, this will enter 10,000 kilometers. Okay, and then what happens is this will be separated. Okay, and this will be burst out in the atmosphere. Okay, so that there will be not any space debris. That's the reason this will be separated and it will be burst out. Okay, and here what's happening is, here the weight of the launch vehicle is also decreasing. Yes, now it will move with a greater speed, with a less fuel, with a less fuel. Now what happens is, after 10,000 kilometers, this will also burn and it will be separated and it will be burst out in the atmosphere again, in the space again. Okay, fine. Now the weight is further reduced. The weight is further reduced, and then slowly this will burn, and this will take to another 10,000 kilometers. See, that's the reason you can see slowly the size of the fuel is decreasing. Can you observe this? Here the size of the fuel is more, here a bit more, here less. Okay, and this is the final stage. Okay, already 30,000 kilometers are done. Now we are left with 6,000 kilometers. Now for this 6,000 kilometers, we'll give the final burst and we'll enter this satellite into the orbit, and we'll enter this satellite into the orbit. Understood? Yes. Okay, so fine. In the vehicles we'll use petrol and diesel, in the rocket we'll use propulsion. Fine. Okay, now generations of launch vehicle. Keep a heading as generations of launch vehicle. Generations of launch vehicle. Generations of launch vehicles. Okay, so first generation launch vehicle is called as SLV. What is called as SLV? SLV means satellite launch vehicle. Satellite launch vehicle. Satellite launch vehicle. It has 4 stages of fuel. How many stages? 4 stages of fuel. And the 4 stages are solid, 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 solid. 4 stages are solid, 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 solid. Now now you guys have seen this stages. Okay, so here for this launch vehicle we have 4 stages, and every stage is filled with solid fuel. Okay, let's say coal. Okay, generally it is not coal, but we know solid fuel is coal, so let's consider this as coal. Okay, so now you tell me, if we are using coal, then obviously the efficiency will be less. I mean, the calorific value will be less, and the pollution will be more. So this is first generation. So we are not developed. Slowly we'll move to liquid. Okay, and slowly we'll move to cryogenic. Gases we cannot do, because see, I have already told you, if we are transporting gases from one place to another, what happens? Because of the frictions, okay, the ship will burn out. It will burst. Yes. So here we are playing a game with rocket launching vehicle. Okay, so here more friction will be there. If you are using this gaseous kind of fuel, what happens? After going to 1-2 kilometers, it will burst out. Okay, that's the reason here in the first stage we'll start with solids. Slowly we'll move to liquids, and slowly will move to cryogenic engines. Okay, so here gases will not be used. Instead of gases, what will be using? Cryogenic engine. Okay, now write down. See, this capacity is, it can carry 50 kgs. It can carry 50 kgs, and it can travel 400 kilometers. So lower Earth orbit. Lower Earth orbit. Lower Earth orbit. See, first we have tried this SLV. SLV 1 failed, SLV 2 failed, and we succeeded with SLV 3. SLV 3 in 1980, and the satellite we launched with this SLV 3 is Rohini. And the satellite we launched with this is Rohini. So first generation clear? First generation satellites are called as satellite launching vehicles. Okay, 4 stages will be there. All the 4 stages are of solid kind of fuel. Okay, so here the capacity is 50 kgs, and it can move to a distance of 400 kilometers, which means lower Earth orbit. Okay, fine. And the first SLV we launched is SLV 3 1980, and the satellite is Rohini. Okay, now second generation. Second generation. Second generation. Second generation. Second generation launching vehicles are called as augmented satellite launching vehicles. Augmented satellite launching vehicles. Okay, now see, still we don't have the technology, but we want to increase the capacity. Before it used to carry 50 kgs, now we want to increase the capacity, and we want to increase the travel distance as well. So the only option we have is increase the number of stages. Before we used to have 4 stages, now increase the number of stages. 5 stages it will be. Okay, and all the 5 stages will be solid, and all the 5 stages will be solid. Okay, so here what we are doing is, see, generally if we want to increase more speed, then we have to use more fuel. If we want to increase more weight on the vehicle, then we have to use more fuel again. Yes, so if I mean, see, in a bus what happens, almost 20-30% are traveling, so bus will take more fuel. In a bike, only 2 people are traveling, so only bus bike will take less fuel. So here we want to increase the weight, and here we want to increase the travel distance. We don't have technology, so simple formula is increase the fuel. Okay, so here we have 5 stages. How many? 5 stages, and all the 5 stages are solid. Okay, so here capacity is 150 kgs, and it will also move to a distance of 450 or 500. So write it as lower Earth orbit. Capacity 150 kgs. See, in your examination, they'll directly ask you this question: how many stages are there in second generation augmented SLV? 5 stages. All the 5 stages are okay. Next, third generation. Third generation are PSLV, Polar Satellite Launching Vehicle. Polar Satellite Launching Vehicle. Okay, so here our main motto is, we want to increase the weight. Second one, we want to increase the travel distance, altitude. Okay, so first thing is increase the fuel, that we have tried in the second generation, but it didn't worked out. Merely 100 kgs increased, and 50 distance increased. Okay, so here what we have done is, we have tried our level best, and we have replaced the solid fuel with liquid, fuel, solid, liquid, solid, liquid. Solid, liquid, and solid, liquid. Why we came to 4 stages? Again, we want to decrease the weight of launching vehicle. Okay, so obviously next generation we want to decrease the weight furthermore. Yes, we want to decrease the weight furthermore. So here what happens is, in the fourth generation, which is GSLV, yes, geostationary, SLV, satellite launching vehicle. So here what we'll do, one thing is we want to increase the weight carrying capacity, and we want to increase the distance traveling capacity. Okay, and on the other side we want to decrease the weight of the launching vehicle. Okay, so to decrease the weight of the launching vehicles, we came from 4 stages to 3 stages. Okay, and the first stage is liquid, and then solid, and then cryogenic, and then cryogenic. Okay, so this is GSLV, and we have fifth generation, which is GSLV Mark 3. Okay, right now GSLV Mark 3, GSLV Mark 3. Chandrayaan 2, Chandrayaan 3 we have launched with this launching vehicle. Okay, and this is also called as LVM 3. LVM 3. LVM 3. This is also called as GSLV Mark 3 or LVM 3. Okay, so I feel today you guys are exhausted. You want me to continue, or you want me to take the class for tomorrow? I think today it's enough. More technical things I have already given. Okay, final thing I want to show you. See, this GSLV Mark 3. Okay, now we'll see what all the things we have launched using this GSLV Mark 3. Okay, first I'll show you these things and then I'll leave you for the day. GSLV Mark 3. See, this is GSLV, and we have 3 stages, 1, 2, and this is third stage. Okay, so if you can click here, that will tell you, I mean, what kind of fuel they have filled here. This is, I mean, I have told you. Yes, third stage is cryogenic stage. Okay, that you can see here. I mean, after going home, you can try it out. Now, I want to show you something. Yes, right on this table. Okay, not everything, at least these two things. Chandrayaan 3, July 14, 2023. Okay, and the vehicle which we are used is launch vehicle is GSLV Mark 3, and this is also called as LVM 3. Okay, and Chandrayaan 2, LVM 3, July 22, 2019. Okay, so these two things we have launched using GSLV Mark 3. Till now we have launched 7 using GSLV Mark 3, and that 7 details you can see here. Okay, so after going home, open this list and write down in your notebook. Okay, fine. So bye for today. I'll meet you guys tomorrow.